B channel is essentially an Alfa Laval designation. Now we have 3 nominal channels for a normal plate heat exchanger. The B channel being our thinnest channel gap. So you have very tight corrugations. And the tighter the corrugation, the more turbulence you have, the higher film coefficient and therefore higher heat transfer. As the channel gap increases, so we have B, P for Peter and M for Mary. So each channel gap gets slightly larger. But as the channel gap grows, then your turbulence decreases. Pressure drop decreases, heat transfer coefficient decreases per square metre. So we have the option to actually select the right heat transfer area for the plate to meet the required pressure drop. And it's all a compromise. We can also change the angles. So this is what we call a high theta plate. Its mate has a much steeper angle. So the steeper the angle, the lower the pressure drop, lower the turbulence. Therefore, for the same thermal duty, you might need more steep angle or low theta plates compared to high. So we have a lot of flexibility. So when you're talking about 3 channels and 2 corrugations, now you essentially got 6 options. So this is, if we're able to sit down with the contractor and the consultant and work with them, we can do that design. But how do we do all that work and then be in a competitive situation? But the rule of thumb is, if you halve the flow rate, you divide the pressure drop by 4. And the reverse is true. And the AHRI presentation that we have, it will show a graph there. I've got it here now, but it shows a graph that for 80% of the time you're running at the average. Summertime you ramp them up, and wintertime you slow everything down. So what you save in winter, you could spend in summer. So you're instead of, if they don't want 100 kPa, maybe the right pressure drop is 80 kPa. And that's what you design on. Because in most of the time you're going to be below that as the flow rates all slow down. And the saving there pays for your summer.